Okay, in this video we will try to identify the region of operation of this MOSFET. So we are considering few process parameters of this MOSFET, which is Kp, which is 200 microampere per volt square. The threshold voltage of the MOSFET is 0.4 volts. This is the equation, that is the circuit diagram that is given, which has a VGS of 0.4 volts, 0.6 volts, and a RD of 10 kilo ohm connected to the drain. VDD is 1.8 volts. So since we are asked to find the region of operation, we can start by assuming let the MOSFET M1 be in saturation region. So we know that if we know the drain current ID, then we can able to find out what is VDS. Once you know VDS, so then depending on VDS sat, which is nothing but VGS minus VTH, we can say whether the MOSFET is in linear region or not. Of course, we know the expression for VDS by writing the KVL for the outer loop as VDS is equal to VD minus ID RD. So let this ID be ID sat. So what I'm trying to do is, I'm just trying to substitute the value of ID as half Kp W by VGS minus VTO into RD. So this happens to be the expression for VDS. So let us try to find out what is the value of VDS using calci. So let me just substitute or enter this equation as it is. So what I have is, since I want to find what is VDS, so it is 1.8 minus 1.8 minus, so I'm going to just substitute all other values, which is now 1.8 minus we have 0.5 into 200, so it is 200 into 10 power minus 6. So we can type it as 200 into 10 power minus 6, which is now we can simply type it as exponential minus 6. So this is 10 power minus 6 into WL ratio is 10 divided by 0.18 multiplied by, and VGS minus VTO is 0.2 whole square. So this is whole square. I can actually calculate what is the value of VDS, which is now now 1.799 volt. It is not 1.799 volt because it is 1.8 minus ID into RD. I didn't multiply RD, so I had to multiply RD now. So let me multiply RD as, which is 10 exponential 3, which is 10k. If you substitute now and find out, it's actually coming out to be minus 0.442. So now the VDS that is coming out to be minus 0.4422. If you can see, since you applied a VDD of 1.8 volt, there cannot be a voltage between this drain and source which is negative. So this is not a valid answer, meaning to say the assumption of MOSFET M1 in saturation is wrong. So MOSFET is not in saturation region. So in such case, what to do? So since VDS is coming out to be negative, so it's not in saturation region. So we need to verify whether it is in linear region or not. So now in this expression of VDS is equal to VDD minus ID RD. So let me substitute this ID in terms of linear. So we know the expression for linear current. Now here the linear current is given by ID linear is equal to half Kp W into 2 times VGS minus VTO into VDS minus VDS whole square. So now let us find the value of ID from this. To find the value of ID here, we have to know what is the value of VDS. Since we don't know the value of VDS, we cannot find ID linear. So let us substitute the value of VDS, which is, as per this circuit diagram, is VDD minus ID into RD. So we are replacing this VDS by VDD minus ID RD. So this VDS square by VDD minus ID into RD whole square. So now we can find the value of ID, because in this entire equation we know all other values except ID. You can see this is not known. You know half, you know Kp, you know WL, you know this constant, VGS is known, VTO is known, VDD is known. Again this ID is not known. RD is known, VDD is known, this ID is not known, again RD is known. So in this entire expression, the unknown parameter is ID. So we can easily solve for that. So let us try to edit this equation onto your calcium, then try to get the value of ID, which is now corresponding to a linear current. So since it's an unknown parameter, let me enter it as alpha A. So if you can see here, I'm using a calcium which is fx-991MS, 991MS. So I have edited alpha A because current ID is unknown parameter. Alpha equals, and what you have this as half into, it is 0.5 into 200 exponential minus 6 into 10. Okay, let me just open the parenthesis. What I'll do is, 1 second, so let me delete alpha equals 0.5 into 200 exponential minus 6 into, open the parenthesis, 10 divided by 0.18, which is doubly well, close the parenthesis, into, so we did till here, then open the parenthesis. I have opened the parenthesis, again it is 2 into, again open the parenthesis, it is now VGS minus VTO, which you can directly write as 0.2 because we know that, and into VDS. VDS is actually VDD minus IDRD. So it is, VDD is 1.8, ID is alpha A into 1, it's actually RD is 10K, so 10 exponential 3, close the parenthesis, and then minus, open the parenthesis, 1.8 minus alpha A into 10 exponential 3, close the parenthesis, square, whole square. Why it is whole square? It is VD minus IDRD whole square. Again close the parenthesis. So now you have to solve for A. Shift calculate twice. So let us wait for some time. You'll get the value of ID. So we are looking for the value of ID now. Let us see how much is the ID. It will take some time. You can see now it is coming out to be 1.69 into 10 power minus 4 ampere. Now this 10 power minus 4 is not a standard value, so you press this ENG, you'll get the engineering value, which is 169.72 microampere. It is 169.72 microampere is the value of ID, which corresponds to linear. Now let us try to find out what is VDS now. So what is VDS now? It is VDD minus ID linear. Of course, let me substitute it as 1.8 minus 169.72 exponential minus 6 into 10 exponential 3. Now this is actually VDD minus ID into RD. If you look for the value of VDS, it is coming out to be 0.102 volt, which is nothing but 102.8 millivolt. This is actually 0.1028, which is nothing but 102.8 millivolts. What is VGS? VGS is actually equal to 0.6. So VTO is 0.4. So then VDS SAT happens to be VGS minus VTO, which happens to be 0.2. So VDS SAT is 0.2, but VDS is 0.102. Therefore, VDS is less than VDS SAT. So MOSFET is in linear region. So now we can say that since VDS is less than VDS SAT, the MOSFET is in linear region. So what is interesting to see is how do we find the value of ID, because ID is not known immediately. So to find the value of ID, when we assumed it as linear, the VDS is coming out to be negative, which you cannot take it as a valid answer. So then to find ID linear, you don't know what is VDS. To know VDS, again you are writing that VDS as VD minus ID RD. In this ID is again unknown. So we substituted here and then we entered this value onto the calci as it is and we solve for this ID. So this way we can comfortably find an unknown parameter when an unknown parameter is on either side of the equation. Hope this is going to help you. Thank you.